Hey everyone, welcome back to BigBrains chip. Today we are solving a very common binary search interview problem called search in rotated sorted array. It looks like a normal binary search problem, but there is one small twist. Let's see how we handle it. So we are given a sorted array, but it has been rotated at some point. We are also given a target and we need to return the index of that target. For example, the original sorted array is something like this, and after rotation it becomes something like this. So our target is 0. So the answer is index 4. We could simply scan the array and find the tag, but that takes O of n. Since this was originally a sorted array, we'd like to use binary search and get O of log n. But normal binary search needs the array to be completely sorted, and our array isn't. So what can we do? Here's the important observation. Even though the entire array isn't sorted, at least one half will always be sorted. So at every step, we find the middle and figure out which half is sorted. Once we know that, we can check whether our target belongs inside that sorted half. Suppose the left half is sorted, then I check whether my target lies between the left value and the middle value. If it does, the target must be somewhere in the left half, so I search left. If it doesn't, I can safely discard the left half and search right. Now let's look at the other possibility. Suppose the left half isn't sorted, then the right half must be sorted. So now I check whether the target lies between the middle value and the right value. If it does, I search right, otherwise I search left. So that's our entire algorithm. We start with left and right pointers and calculate the middle. If the middle is our target, we are done. Otherwise, we determine which half is sorted. We check whether target belongs to that sorted half. If it does, we search there. If it doesn't, we discard that half and search the other side. And we keep repeating this until we find the target or search space becomes empty. So we can start solving the problem. We'll be having the two pointers left and right. The left points to the 0th index and the right points to the last index, so nums minus 1. So we can start similar to the binary search. So while left is less than or equal to the right, now I have to calculate the middle value. So m equals left plus right solution 2. So now we need to do a couple of checks. So first, if the nums of m already equals the target, I'm just gonna be return indexing. So the next case, in case if nums of L, if it is less than nums of M, that means the left half is sorted. So in that case, I have to do another check. If the target is lying between the left and the middle, so nums of L less than or equals target, because the target can actually be the left value itself. And between nums of M, if that happens to be true, I just have to consider the left half. So the right pointer needed to be updated like m minus 1, or in the other case, if the target is not lying in the left half, it's obviously on the right half. So I just have to increment the left pointer. So this is the case for left array being sorted, or to be more specific, left subarray, or in other case, if the left array is not being sorted and the right subarray is sorted. In that case, we'll be having, or inside just an else block we can have. So we can have an if block if nums of the mid value, if it is less than target, and or otherwise less than or equal to nums of. If it lies between this range, then it's obviously proven that the target is somewhere on the right half. So I just have to do left equals mid plus 1, or otherwise right is equal to mid minus 1. That just means the target lies in the left half. So if none of these is true, I just have to return -1. Let's see if it works. Oh yeah, okay, perfect. Oh, we have a wrong answer. Expected is 1, but I'm getting -1. What's wrong? Mm, yeah, gotcha. Now let's see. Yes, it works. Yeah, perfect. The entire trick is just this. Find the sorted half, check whether the target belongs there, and eliminate the half you don't need. That's how we turn a rotated array back into a overflow in binary search. And that's GYP 3. Don't memorize DSA, recognize it.